Hello, everybody, and welcome back to Money with Michael. Today, we're going to talk about the best way to develop trading bots. It's probably easier than you think and more complicated than you think at the same time. Now, first thing you got to do is you got to develop a model. We've talked about this in a prior video. We gave the example of the mean reversion, and the basic idea behind a mean reversion model is price moves a certain far away from the fair value, and then it has to snap back in some way. Well, you need to code that into some kind of code with all the variables in it. Every different way you could define fair value needs to be probably in a switch statement. Every filter you want to use is in a switch statement. You might even need to do a switch statement if you have different ways you want to calculate that distance, how far away it has to be before it comes back. The point of this is you set these up as these options that can be used in this one big giant model of a strategy, and you set these as inputs. So if you've got 5 different ways that you could be to define fair value, you'll put fair value switch, and you'll have an input variable that says, hey, fair value calc, and you'll set it from 1 and go to 5 in steps of 1, and that way you can try every one of them, and you can test it on data and see what actually works. We'll give you some better examples of some future videos, but really this is the core of the process. Once you've developed the model, now you've got to actually go mine potential strategies and find what's junk and what's not. Now, we do this to the optimizer, and most packages today have either an exhaustive regular optimizer or a genetic algorithm optimizer. MT5 has this, TradeStation has this, Ninja has this. I'm sure Multicharts and the others do as well. Now, when you code up one of those models and you use, every indicator possible as a filter, every way you can measure those things and have it go up, if you want to do an exhaustive optimization, it could take months. You could have hundreds of millions of possible iterations, and you just really don't have the time to go through that. So in math and everything like that, we've come up with algorithms to solve these kinds of large ones. And the easiest one to go to is a genetic algorithm, and it operates a lot like it would in nature. If you think about genetics, it's basically going to look through all of your pull a couple of the options out, test them through. If some of them show promise, then it's going to say, hey, looks like treating the 20 moving average is the fair value of this one. All right, well, let's hold that constant and let's try several different of the filters and things, see if we can make this better. Let's try different ways to calculate the distance, see if we can make this better. And it continues to improve upon that. So it treats it like children, like the 20 moving average had children that were 20 moving average in the RSI, and they had children, and it finds the best ones, and it comes all the way down. It's based upon, how evolution works. And if that has your head spinning, well, you might not care about how it actually works, but I thought it was a really cool thing from nature that we've taken back into math and we can apply it into trading. This diagram here is a flow chart of an explanation of how a genetic algorithm is designed and how it works. This is not mine. I got it from the PhD thesis of Frank Dieterle, and here is the link to his PhD thesis. It's got a lot of cool things in there if you want to understand it, if you really want to get more educated on things. You can also learn more about these in a lot of other ways. You just have to get involved, do some Googling, and read it again, because it is pretty heavy stuff. But this genetic algorithm is going to go through and select these candidates and find ones that we can use for strategies. Now, you have to determine in this pool of genetic optimization how many generations of what. So, that's one of those kinds of things, right? So let's think about this in general terms. If I found I wanted to use the 20 moving average to get 100 generations of these things, it would first come down the next generation and try 100 different ways to calculate, say, that distance. Then we'll take the best ones of those and pull them down to find and go through all those different ways that 100 more different ways that they could calculate either distance or do a filter, and slowly go down until they have 100 generations of it. Now, this is the minimum I'd recommend, is 100 generations of 100, so you can get the best out of those. When I do my own, I can do as high up as 100 generations of 5,000. Just depends on how much time I've got and what I'd like to do. And this way you get a good sampling of all of these and look of all the different possibilities and find what might work best on your data on your 1 year or so that you want to mine to see what might work. So you set up your optimizer. You've got you've got your model set up. You put it through the optimizer. You set 100 generations of 100, and it's going to spit out to you some potential strategies. But the first thing you have to choose is your fitness function. Do you want it to find the best possible combinations to get something custom, like the TradeStation Index? Do you care about profit factor, Sortino ratio? Another really great one is net profit to drawdown. Probably the least useful is net profit because it could have been made $50,000 and had a drawdown of 200, but it just happened to make 50,000 to be the the highest one in that. It could still be junk. So Genetic Optimizer will go through these generations, find the combinations that and then return to you the combinations that have the best of these fitness functions, whether it's profit factor, Sortino ratio, or anything of the like. Now, TradeStation is great because you can save the top 8,000 results of any of these runs. So they may run through a million. You get the best 8,000. They may run through 50,000. You get the best 8,000. NinjaTrader is different. NinjaTrader defaults to just 10. And you have to actually tell NinjaTrader that you want to have more. I recommend you do at least 50. Now, NinjaTrader, as you might know, it's a resource beast. You put 1,000 in there and things like that, and you could very well lock up that machine because it's based on .NET, and .NET is garbage when it comes to memory management. That's why I prefer TradeStation again on this part. NinjaTrader has a lot of great features, but its optimizer hogs resources. You can't keep a lot of the results back and things like that. Now, so you've coded up your model. You've selected the inputs, you put the parameters in, you've done genetic optimization. It's returned the 8,000 top ones of your results. That may have taken you 2 hours, 3 hours, a day, whatever your computer fee allows. That doesn't mean that these 8,000 are now ready to trade, right? These are just potential candidates, and we ran them on 1 or 2 years of data so that we could have some out of sample to do a robustness testing and really see what works, right? So when you take these 8,000, you look at them and maybe you pull the 20 you like the best or the 40 you like the best. You get some variety in there and you put them through the rest of your robustness testing. Maybe they walk them forward on 10 years. Maybe you do cluster analysis. Maybe you do noise analysis. Maybe you do Monte Carlo. You do all those things, whatever your usual fitness level is and what you like. And then you decide, are these ones that I'm going to trade or not? And they're going to be some you can keep. The vast majority, the vast majority are going to be junk. And you may run this 8, 9, 10 times and not find one strategy you want to run. You may run it 100 times and not find one strategy you're going to run. But the thing is, when you find a strategy that goes through all that, gets through your robustness testing and does other procedures, as long as your robustness procedures and your strategy selection procedures are data-driven, mathematically sound, you've got the best chance you have to make money. No guarantees, but it is the best chance you're going to have to make money. And that's what I do to develop my portfolios. Sorry to hear that siren because, of course, that's the way it works. You can't go anywhere without sirens anymore. So now that the siren's gone, I'll continue. I don't know if you heard the siren or not, but there was a loud siren in my background. This is how I develop my portfolios and my algos. I develop a model. I run it against the data, a small segment of the data. I take out the best ones of candidates from there. I run them through robustness testing procedures, drawdown tests, noise tests, all that kind of stuff. And only the best ones come out. And just because they're tradable doesn't mean they fit in my portfolio. I put my portfolio together based upon which ones of these have best correlation analysis, which one of these have the best fit for my purposes. And that's really how you survive. It's rushing to skipping these thoughts and these spots, these steps, and not actually testing these out that are going to get you. And that's how I do mine. And hopefully that someday that'll be how I do them for a fund or something else. But I don't do any of that stuff currently. I may someday put a couple portfolios together and lease them out. You can do it for TradeStation and Ninja. Not doing any of that stuff right now, just kind of documenting the journey. But stay tuned for those kind of things. If you have any questions or comments, put them in the at the bottom, and hit that subscribe button. I'm probably saying it too late. If you're getting any value from this, and I'll keep doing it, and you'll eventually get my whole process. Thanks.